Okay, this is number 2 on 4.17. I thought I would do some word problems since this year students are having more trouble with them than in the past. Okay, so some students, when they did this assignment, what they did was they just tried to write an equation, solve it, and then they circled their answer, and they found that they really didn't answer the question. If you read this, it says separate the number 78 into 3 parts, and then they tell us some more about the parts. What they're wanting to know there is what is the first part, the second part, and the third part. They want to know the 3 parts. You don't want to say x equals something because they didn't tell you anything. So what you've got to be careful to do, and part of the proper procedure, and what I expect of students when they're working word problems, is to follow that little blue box that you had at the beginning of 4.17 that laid out, actually at the beginning of 4.16, that laid out the steps to doing word problems. I want to see all these parts, and I'm going to start counting off if I do not see them. Because first thing you need to do is you need to define your variables. Okay? I see they're talking about 3 parts. So I've got a first part, a second part, and a third part. So let me go first part, second part. I'm going to describe each one of these in third parts. Now when I get done, I can come right back to where I have written all this stuff and get all the things they want. I'm probably going to have x equals something, but I'm going to have to plug it in to find all these parts. And I want to clearly communicate the first part is this, the second part is this, the third part is this, or the 3 parts are. You could even say it that way. All right, how am I going to describe these things? Well, we've talked in class about important keywords and word problems. And one of the words that we look for is than or as. And if you sometimes it might not be easy to find it. Sometimes you may have to read it into the problem. Maybe they, just according to regular speech, they may have it's implied, but it's not there. But if you look in this problem, it's actually there. Here's a than. Why was than important? If you remember, than it has a couple of things that it does, and as is a similar type word. But here we have than, so we'll just talk about than. Than does 2 things. It's a switching word. For instance, 6 more than means I'm going to add 6 to something, okay? And we'll talk about what we're going to add it to in a minute. But than also has another thing that can make it useful in a word problem. The thing mentioned after than or as usually tends to be the thing you want to call your variable. So if you look, what comes after than? This, the first part, and I'll underline it in yellow. This is probably what I'm going to want to call my x. So we're going to call the first part x. That will make the other parts easier to describe. It's not that you have to do it this way, it just makes the rest of it so much easier if you'll do this, okay? Alright, so now we got the first part. Let's go back to the beginning. Separate the number 78 into 3 parts so that the second part, okay, let's describe the second part here. I'll underline it in green or something. The second part is, that means the second part is equal to, so second part is equal to twice the first part. Now twice means multiply something by 2. What are we multiplying by 2? Let me write the 2 down. I'm multiplying 2 times the first part. Well, how did I describe the first part? I described it as x. So that becomes 2x. And now they go talk about the third part. Okay, they say the third part is, so the third part equal 6 more than. We mentioned a minute ago that 6 more than means we're going to add 6 to something. Write it second, because when it doesn't make that big of a difference here because it is addition. But if it had been 6 less than, we would have had to subtract 6 from something. And so many people put 6 minus whatever instead of putting something minus 6. So here we got 6 more than. We're going to add 6 to something. What are we going to add 6 to? 6 more than the first part. So we're going to add 6 to the first part. How did we describe the first part? We wrote it right here. We described it as x. Now, what does this mean? Separate the number 78 into 3 parts. If I had a pile of pennies, say I have 100 pennies, and I put them into 3 different piles, I separate them into 3 piles. Wouldn't I add all the piles together to get all the pennies together and combine to equal the 100 pennies? Well, that's what they're sort of doing here. They're saying the first part plus the second part plus the third part equals 78. What I usually do, and I'm not going to make you do this, is, but it's helpful, and I kind of would recommend it at least. The first number, I know that's hard to read, but I'm writing with a stylus and doing the best I can, plus, I'll just put second number plus third number equal 78. Some of you do this, and this is also good. First number, and you'll put plus second number. This is a good thing I saw people doing on their paper. Third number. You're getting the concept down before you go put all the little pieces together, because sometimes those X's and things don't look like anything in our brains when we write them down. All right, so now I know what the parts are. The first part was X. The second part, over here in green, was 2X. And in blue, the third part was X plus 6. There's my equation. Okay, so now I've got to solve it, right? So I'm going to put all the things together. And remember, Lazy Math Guy does not write a 1 out front of an X, but he means there's an X. There's one X. So we have to say, okay, I'm going to combine like terms here. I've got 1X and 2 more X's. That makes 3X. Oh, and look, here's another X, which is another 1X. 3X plus 1X is 4X. Okay, so I combined all the X terms together. And now I've got, let's see, all I've got left is this plus 6 up here. And on the other side, we have 78. Now, if I want to solve it, remember, there's nothing to simplify on either side. That's what I was just really doing, was doing my simplification first, wasn't it? I got the left-hand side and combined all the terms. Okay, so got all the variables on one side. That's the second thing we actually check before we start doing PEMDAS backwards, because we don't want to be just moving stuff all over the place. We want it to be nice and cleaned up before we start trying to solve it. So when we solve it, if you remember, we're trying to get X by itself. So I recommend you circle it. Remember, this is just stuff we've already done it for a couple of chapters now. And what we're going to do is we're going to do PEMDAS backwards. We're thinking the first thing I'm going to do, if you think about PEMDAS, add and subtract. If you start backwards and go back towards the front or top of PEMDAS or front of PEMDAS, you'd add or subtract anything first. So is there anything added or subtracted to the X term? Yes, there's a plus 6. It's the opposite of a plus 6, because we always do the opposite, minus 6. Okay? So now we got 4X plus 0, which is just 4X. Most of the time we don't write the plus 0 down. And then 78 minus 6 is 72. And if I want to find out what X is now, all I got to do is divide both sides by 4. And I'm going to get X equal 72 divided by 4 is 18. Now, what a lot of people did on their paper is they just circled 18. Well, there were 3 parts to that, right? You had 3 parts that added up to 78. Did you answer the question? That's why you always got to either go back and read it again when you finish to make sure you answered the question. That's always the recommended thing to do. Or sometimes if you've come up here and you've done this stuff up here that I'm circling, if you've written out things, you can catch what all you're supposed to do, because the answer is not 18. 18 is one of the 3 answers, so you didn't answer the question if you didn't, tell all this. So X is 18. I'll put it up here. Well, then there was the second part. It was 2X. Well, if X is 18 and I plug 18 in, 2 times 18 is going to give me 36. And then X plus 6 would mean take the 18 and add 6, which is 24. Okay? So and here's what you should do. When giving your answer, you should write it in a complete sentence. You could word this. The first part is 18, the second part is 36, the third part is 24. But if you think about it, you could also word it like this, because a lot of people just don't like writing, and so that's why they don't want to do this, I think. I'm sorry, it should have been the 3 parts are 18, 36, and 24. Okay? And so that would be your answer. Always write your answer in a sentence. In the past, I've kind of said, oh, you don't have to make a complete sentence, but I'm changing my mind because I really do see that people just don't understand about communicating the answer clearly, and I think if I make you do that, it's gonna help you understand a little bit better what you're supposed to do. I'm going to try to fit number 4 on this video as well. If it runs out of time, you can finish it up. All right, so again, we're thinking, all right, we've got, we're looking for, we want a number. That's what, let's call our number X. We know we're supposed to find the number. So let's call it X. So X is our number, the number. Okay. Now, so let's start reading. If 9 times a number is decreased by 6, the result is 111. Okay, one thing I always tell you guys is that is means equal. Well, if you look, we got 2 is here. Which one is the equal sign in an equation? If I'm trying to kind of think about my equation here, is this number is decreased by 6 is what goes on the left side, what goes on the right side? Well, if you read it, it says the result is 111. It's a number that's going to go over here. I'm going to do something to a number, and when I do all this stuff to it, it's going to equal 111. So let's start reading. We called our number X. I kind of noticed the word number is right here, so I'll put an X here. So let's start reading at the beginning. If 9 times a number, well, 9 times a number, that means 9x. Okay, so we're talking about 9x here in this part right here. If 9 times a number is decreased by, now decreased by, that's the same sort of thing as less than, isn't it? Decreased by means I'm going to subtract 6 from something. So 6 is going to get subtracted from something else that I'll put in a blank. If 9 times a number is decreased by 6, oh, it's this 9x that's decreased by 6. The result is 111. Oh, okay, there's my equation. 9x minus 6 is 111. What is the number? Okay. Now, if you look here, we're only looking for one thing, and we actually call the thing we're looking for x. So when I get done, my answer will be x here, but it's only because, I've been careful about looking to see how they describe stuff here, and what they've asked for is just a number. So I did call that x. So we're going to solve for x now, and our answer will be x here, okay? All right, so we don't have any like terms to combine on either side. There's nothing to simplify on either side, and all the variables are on one side. Remember, those are the first 2 steps we do when we solve equations. So now what we're going to do is just think PEMDAS backwards. So we add or subtract first. So, oh, there's a subtract 6 from the x term, so the opposite of subtracting 6 is add 6. And again, the reason we do the opposite is we want this to add up to 0, because if I have 9x plus 0, it really just is plain old 9x. That's why we did it. We're trying to get this x by itself. That got rid of it, and it went over on the other side with the other numbers, so it's 111 plus 6, that's 117, right? All right, now I've got 9x equal 117. How am I going to get x by itself? Well, it's attached to 9. It's smushed together, which is invisible multiplication. So we say, well, the opposite of multiplying x by 9 would be to divide it by 9. So we divide both sides by 9. 9 over 9 is 1 over 1, which is 1x. But remember, the lazy mathematician, he only is going to write down x equal, and then that goes in there, let's see, 9 goes into 11 once, bring down your 2, 9 goes into 27 13 times. So the number is 13. So go ahead and write that as a complete sentence. That way you've got a better chance of having answered the question that the problem asked and not having accidentally just found x, circled it, and gone on, which actually would have been the right answer here.